we'll turn our focus to our special speaker from Oracle today, Billy Korando. He's a Java developer advocate of the Oracle's Java Platform Group. He has over a decade of hands-on experience in Java. He's a JUG leader and co-organizer of the Kansas City JUG in Missouri. He's very passionate in helping developers to be productive. He has a wide range of experience, project experience in the project initiation, deployment, testing, and validation, and automation, anything else. So outside of work, he enjoys traveling, kickball, and is a #1 fan of the KC Chiefs. So with this, welcome, Billy. We're all excited having you here. So
awesome. Yeah, thank you for that introduction. Thank you for the invitation, Mary. Thank you for the introduction. And yep, happy to be here. And without much ado, let's go ahead and jump in. As mentioned, my name is Billy Korando, Java developer at Oracle. And you can find me on Twitter at Billy Korando. And we're going to be looking at Java 18 and beyond. And as Mary said, this is very timely as Java 18 was just released Tuesday. A few important notes. One, please ask questions. I am here to get you up to speed on kind of what has happened with Java since really we're going to be really kind of starting with JDK 11. But if you have any questions at any point, definitely ask them. I am monitoring the chat log. So definitely, at least when I'm doing my presentation, if you have questions, put them into the chat log. And then at the end of the presentation, we can definitely have a audio Q&A segment as well for sure. Again, you can find me on Twitter at Billy Korando, and you can email me at billy.korando@oracle. And a link to this slide deck is at my GitHub here. So you can definitely check that out if you want to refer to it back later. If you leave with an intense desire to know more from this presentation, we have a lot of great sources that my team here at Oracle works on. We have dev.java. We launched that back in last September when JDK 17 was released. And so we have tutorials and content. You can also find like all the other jugs around as well. So definitely check that out. We also have Insight Java, and that's a good way to kind of keep up with what the actual underlying development with the JDK itself is happening. So we have like interviews with the actual OpenJDK developers, which would be on the Insight Java podcast. We also have a YouTube channel where we post a lot of content there. Actually, today, we released a new video for our Insight Java newscast where I actually break down some of the JVM improvements that came with JDK 18. Then we also have the Sip of Java, which I also typically do. I release that on Mondays, which is just a minute-long video around just various Java topics. So check that out Monday. And then we also have Jeff Cafe, where Jose Palmard, he gives really good in-depth videos on many different topics, and actually kind of more recent ones. He's also done some more coding examples as well, which has been actually really awesome. But all that bureaucracy stuff out of the way, you're here to learn what's kind of been going on in JDK, particularly with also like JDK 18. So the agenda for this presentation, as you can see here, it's going to be, we're going to look at some of the new language features. Then we're going to get into the new runtime features. And then we'll also kind of look at the deprecation removals and some other changes that you should know about. And then the last part is we're going to look at a little bit into the future as to what will be coming with Java in these upcoming releases. So with that said, let's get looking at the language features. And the first one I want to start with is text blocks. This was added in Java 15, and the JEP for it is 378. When I say JEP, that means a JDK enhancement proposal. And so whenever there's a somewhat significant change to the JDK, that goes through the JDK enhancement proposal process. And for text blocks, that is 378. So if you go to this link, OpenJDK Java.NET JEPs 0, you can see all the different JEPs that are currently being worked on or have been delivered, as well as some that have been proposed. And if you were to put in like the JEP number I put there, that's not what I wanted to do. If I put 378, this gives a really good detailed breakdown about the feature that I am covering. So obviously with much more depth I could really get into in this presentation for each of these individual features. So if you want to know more about like say text blocks or some of these other features I'll be talking about, definitely check out these links as it will give like the motivation, the history, and then also the usage for these features. So I'll mention that for every of the features that I'm talking about. So as Java developers, so any good framework for performing a series of validations in a business flow. We'll get to that maybe at the end, since that's a little bit outside of this presentation. But yeah, I'll get back to that. So definitely when we get to like the end of the QA, we'll get to that. And thank you for posting the link, Mary, to the JEPs. So yeah, text blocks. I wanted to start with this because I think this is going to one of those be big obvious wins for developers, because at some point we have always had to kind of work with some sort of like markup language within our code. You know, in this example, I'm using JSON, but you know, HTML, XML, SQL. We've all had to do with this some point in our careers, and it's always very painful. Here I have like a very simple Java JSON message, which is just 4 fields, no nesting or anything like that. And because we're familiar with it, we can kind of understand what's going on. But it'd be very difficult to maintain, especially if we get to any sort of real complexity that we would actually see at our jobs. If we had some nesting and stuff like that, it could be very easy to forget a colon at some, or a comma at some point, or a colon even, or a quote. There's a lot of easy ways where this could become messed up, and then you have a bug, or it's just difficult to maintain. So with Java 15, we got text blocks, or 14 or 15, whichever, and they are denoted with a opening triple quote, a new line, and then a closing triple quote. And then within here, the formatting requirements are significantly relaxed. I don't have to put a new line character to say a new line. That is just all preserved actually within this text block. I don't have to escape double quotes. I don't have to put any tab characters in. What this looks like in here is how it would actually then be rendered by the JVM. If you did like system out print line, or however, this is just this string and this formatting is all preserved by it. And these are just normal strings. We have this syntax, but underlined it all, the JVM just treats it as a normal string. So if you wanted to do like string formatting to it and be able to pass in values like I'm doing here, that's totally fine, like you would do it with any other string. Also with this is like, let's say you just need to print some of this text out as like a single line, like you don't actually want to have those character turns in there, and you want to be able to have a return because you don't want to have like a 500 long line character within your code file. On the very last character of it, if you put a backslash to it, then the new line is ignored, and so if I was to print this out, it just would be printed out as a single really long line. One last thing I forgot to mention earlier. Fundamentally, where you want to have white space being ignored, you want to put it to where that is your enclosing triple quotes. So like here, I want all this white space to be ignored. I want when I print it out, like the first line, the first character should be these curly braces. So I just line that up then with the enclosing triple quotes. So that way, like if I was to nest this down some more, and when it suddenly add a bunch of padding white space to it, this will all just be ignored. There's a few things around how this is handled. There is, if you look like if you Google Programmer's Guide for text blocks, it'll give like some nuances around this. But the general rule of thumb would just be kind of like have these enclosing, line up your text with the enclosing triple quotes. The next thing I want to talk about is switch updates added in Java 14. And again, the JEP for this is 361. So this is going to kind of get into like a topic where some of these new language features, they reduce some of the verbosity that, is sometimes criticized Java about. But really, the thing to think about with verbosity, it isn't about typing. Like, at least sometimes when I've heard that, like I always thought about, typing, but like, the amount of typing you do isn't really the constraining factor when you're writing out code. It's more thinking through the process and designing it and so on. But where verbosity becomes an issue is you have like a lot of noise here. Here we have to have like a new line and we have to have the break and all that. It becomes pretty noisy when really what it is like, oh, if you match on case 1, then we want to print out Sunday. If you match on case 2, we print out Monday, and so on. And then within this verbosity, it becomes very easy to actually introduce a bug. Like, let's say you're doing some testing and you remove a break from case 6. Well, of course, switch has fall through by default. So now when it matches on case 6 for Friday, then it's going to also then print out Sunday, which, isn't the behavior that you're really expecting to have. I mean, maybe it is, but, pretty clearly this is probably a bug from what you're expecting it to be. And that's kind of where some of the issues with verbosity comes from, is it creates opportunity. It both creates visual noise, and then it creates opportunities to introduce bugs. So switch has been updated in several ways. So the code I just showed you before is still completely valid. It's not like you're going to go through and update all your code to do this new switch behavior. This is something this is how switch has been expanded. And so one of the ways is with the new arrow operator. And how this works then is when a case is matched, only the code to the right of the arrow operator is executed. And there's no fall through by default. So you don't need to have a break statement in here like you did with the older colon syntax. So this just becomes much cleaner, much less error prone. There's not going to be accidentally if you hit on case 5 for Thursday and then you're also going to print out case 6 for Friday and Saturday or anything like that. So that's a nice improvement. And this is also where I want to kind of touch upon like one of the new things that has kind of happened since we've gone to the 6-month release cadence is the introduction of the preview feature concept, where as new language features are added, they're not just straight up added, they go through at least 2 rounds of preview. So whenever like a new thing's going to be added, like, eventually at some point, there's going to be record patterns I'll touch on. It's going to go through at least 2 rounds of preview before it becomes a standard feature. And this can ensure that we can actually work through any sort of kinks in this new feature before it's actually added that could end up becoming an issue. And I bring that up because like had Java originally had this feature way back when switch was added, of course, this is when it was all in beta itself, we probably wouldn't have done fall through by default. That was just kind of following what C++ was doing, or C, or both. And we thought we needed it because that's, just a follow it. But really, no one really liked fall through by default for the reasons I kind of covered. And so by going through this preview process, we make sure that these new features that are being added are much nicer and much cleaner, and maybe make sure rounding out some of those rough bits around it. So I do like that new change, and this is some of the ways that I can make sure that these new features are actually really tight and good. So that's one of the ways switch is being updated. The other way is you can also write a switch as an expression. So you can yield values out of this. So now if I have cases matched, it will return the string value of Sunday, and so on. Now, when you write it as an expression, it has to be, you have to cover all potential cases. And in most cases, that means you're going to have a default case at the end of it. So some value or an exception is going to have to be thrown when you write the expression. So here I have a default that if it doesn't match on any of these cases, then an exception should be thrown. Also, like let's say in one of these cases, you need to do something more than just return the string value. You can also write curly braces and then actually have a code block in here as well. And when you're writing it in the expression format, then you can end it with the reserved word yield that will return a value. If you have yield somewhere else in your code, like you have like a variable named yield, like this won't cause an error. Yield is only like a keyword, or in this case, a reserved word, when it's within the context of a case. So, this isn't going to be like introducing like a breaking change. And the reason why yield was also used instead of like saying return is to not cause confusion that if you have a switch expression within a method, if you have return here, is it returning out of the method or they switch? So they use the new reserved word yield to make it more clear that you're only escaping out of the switch, not something higher. And of course, you can do these curly braces as well if you're doing it as a statement with the arrow brackets. You can also, if you really like the colon syntax for some reason, you can actually still use that or write an expression with the colon syntax. You can just do yield as well. And of course, with that, you would still have to have, you have to cover all cases. So in most cases, that will mean having a default case as well. But as I mentioned, so like, let's say I had an enum that covered, in this case, again, the days of the week. If I covered all the different values of that enum, then I wouldn't need a default case because I'm covering all potential values for this switch case. So you won't necessarily always need a default case. And we'll see here in the beyond section how you'll see how it's going to be more possible. You won't always necessarily have to have a default case as well. And again, same case as also with the colon syntax. So one really big topic that's going to be coming to Java on the upcoming releases is pattern matching. And the first instance of pattern matching for Java is pattern matching for instance of. I'm sorry, that was a terrible joke with all the puns and instance of in there. But the JEP for this is 394. So again, this is a common thing you've all seen in our code at some point, where we have some sort of type, some sort of reference type, where we, for some reason, it's indeterminate. Here, I just simply put object, but maybe you're getting a value in from outside, or it could be one of several. So we have to do this. If this thing is actually a string, then within the if block, we'll put a string, cast it a string, and so on. Again, it's visually noisy. And this maybe isn't a great example, but like, let's say if it could be one of like 6 or 7 different types, we have to do if else, if else, if else, if else, if else to get through that all. And it becomes very noisy, and there starts to become, a lot of opportunities for accidentally introducing a bug. So now we have pattern matching for instance of, to where we have a test. We'll say, okay, if actually a string is a string, then we'll assign it to this variable, what's called a pattern variable, and then it's available to work with. And so this is what pattern matching is. You have some sort of predicate, some sort of test, and if that test is matched, then you assign it to a pattern variable. And so this pattern variable, or this also introduces a new concept, or at least makes it more relevant, of a concept called flow scoping. So this pattern variable, in these cases now called now a string, it's only in scope whenever the compiler knows it has definitely been set, essentially wherever it knows the predicate is true. So, it's obviously in scope here being set, and then it's in scope in the if block. However, once we leave this if block, it will then be out of scope. So you would get a compiler error here. Here, if I just had like an evaluation statement, this would only be in scope within the bounds of the evaluation statement, but the second we leave it, again, it would become out of scope. So of course, this would also mean that it would be out of scope to the right of an if statement, because by necessity, it could only get to this part of the if statement if this was false. But of course, it would be in scope to the right of an and statement. I probably should remove this slide, but you can kind of get weird with it as well. Not that I would recommend this by any means, but if you put like a not at the start of this if statement, then it would actually only be in scope in the else block. Or if I put like a not at the start of this if statement and then had a throw in here, then it would actually be available outside the if statement or outside the if block. You shouldn't do any of this. You're just asking for introducing a bug at some point, or just confusing someone at some point when they see this. So a lot of the time, what's going to happen is you're going to need to have some sort of variable set the appropriate scope for what you need it to be, and then you just assign it to that within the if block, and you can work with it later. Sealed classes. Added in Java 17, the JEP for it is JEP 409. So what sealed classes allow you to do is it allows a class to define what subclasses can extend it, or in the case of an interface, what classes can implement it. And this can be really good for capturing domain information. again, once again, every organization we've worked at, there's certain domain concepts. Here I'm using user, and let's assume in my organization, a user could really only be three different kinds of things. They could either be a guest, they could be a customer, or they could be an admin. This is pretty simple, but there could be something like transaction types. Like there could only be two different kinds of transaction types, or or a limited number of item types. And before in Java, there was no easy way of kind of capturing that information. It would just have to be kind of explained in documentation. Well, now we can actually both define it and enforce it through code. So what does all these different outlines mean? Well, here, user is a sealed class, and that means I define the different subtypes. Guest is a final class, so nothing can extend it. Customer is a non-sealed class, which basically means it's a normal class that anything can extend off of. And then again, admin itself is a sealed class, which then says who can extend off of it. And what this actually looks like then in code is, in this case, I have used an abstract class, but any kind of class could be a sealed class other than a final class. So yeah, I have my sealed user class, and it permits admin, customer, and guest to extend it. And then for these subclasses to user, admin, customer, and guest, they then have to declare whether they're going to be a sealed class, like it's again also like in the case of admin, which then permits either super user or normal admin to extend it. A final class, like the case is in guest, or a non-sealed class, like the case is with customer, which again effectively makes it a normal class where anything can extend off of it that can have visualization to it, access to it. And we'll touch again a little bit on sealed classes in just a moment again. But one thing I really want to talk about is records, which was added in Java 16, and it's JEPIS 395. And I've kind of said this many times, but I think record, and I'm not the only one, but I think record is going to be one of the most important new features coming to Java since streams and lambdas in Java 8. And that's just going to become more of the case as new features kind of get built upon records that kind of take advantage of it, both language features and then also frameworks and libraries, as they also take advantage of some of the specifics that records offer. So again, the most straightforward and immediately obvious benefit for records is reducing verbosity. So here, like in this example, like within the body of a method, like maybe I'm doing some sort of data transformation, and I have like some of these values, I want to assign it to like some sort of class, and maybe I just kind of want it to be a throwaway class, but it always just kind of takes dozens of lines of code to define that, and you would just never do that within the body of a method because you would lose all meaning, and it becomes difficult to know like, oh, this part is here and this part is the method, and then all in here, we have some other class defining some new type. But with records, all that can be defined within a single line of code saying like, hey, I'm defining a new record. Its name is person. And this person is going to have these 4 different fields to it: first name, last name, title, Twitter handle. And then I can do everything with it. And the compiler will automatically generate equals, hash code, toString, accessors for all these different types, as well as a canonical constructor. The point of records is it makes it a more transparent modeling of data as data. Like I said, just from reading the definition of this record, everything that you really need to know about it. And so with that then there's also some constraints in order to achieve this for records. One, the superclass for a record must always be Java Lang record. And then as a result, you can't extend a record. It can't be abstract. And so as a result, all records are implicitly final. Records, all the fields are final, but it's only cellularly immutable. So let's say if one of the fields is like a list, and then I pass an array list to that record, I could add or remove items from that array list, but I couldn't change out that reference to array list to it. Records can't declare instance fields. And as I mentioned, accessors, hash code, 2 equals, canonical constructor are all automatically generated, but you can also override all these default implementations and add your own, as well as add your own method definitions. Of course, make sure, I mean, really you should never probably override hash code and equals. And if you do, you want to do whatever you can to make sure that that is, doing hash code and equals correctly, because if you're not, then well, you're going to introduce a lot of potential issues into your system. So probably hash code and equals you should never override, but some of these other ones, there could maybe cases where you want to override them. But yeah, example of that here, instead of like the standard way of like the square brackets and then like, the different fields that the standard toString does, I wanted something with like a prettier format, so I can just implement my own toString to do that, print it out a little more pretty. Or, I wanted to add my own toJSON method to print this out in JSON, taking advantage of the text blocks I talked about earlier, can do that just as easily as well. Sealed classes and records also work together really well. As I mentioned, sealed records, they can't extend off of anything, or they can't be extended, but they can implement interfaces. So in this case, I have a sealed interface user, and then at my records of admin, guest, and customer, they all implement it. So that's totally valid, and that can work together really well. One last note I also want to make about sealed classes is you'll notice here I don't have a permits clause. So permits is optional, and if you define like a sealed hierarchy, and within that same source file, you also put the subclasses for it, then the compiler will automatically interpret that as those are the only valid classes that can actually then extend off of that sealed type. So in this case, you don't have to put permits, and these are the only the other classes that are also defined within that same source file are eligible to extend off of it. You can't have permits and then also other classes in that same file as well. That will be a compiler error. And then one last new feature in Java 18 is code snippets. And so this can be really great for library developers and API developers. They actually be able to better demonstrate code within a code or within your documentation than it was possible, because you can also have it to where it will automatically insert code within your Java doc, like I have in this example, where you have this example that I took directly from the JEP, where it shows like, you reference like the source code file name, and then a region, which is just a string matching to then these comments. And then this code here will automatically be added to this Java doc. And of course, as this code changes, then the Java doc will also automatically update it. So that's a way to keep the documentation and the actual code in sync. All right, let's get into some of the new runtime features and improvements. CDS has been updated. Now, CDS, I think it's maybe a somewhat under talked about feature. What CDS stands for is class data sharing. And originally it was added to the JDK all the way back in JDK 5. And when it was added then, it was only for the core JDK classes, and you had to do a little bit of work to actually get it to working. So with JDK 12, we actually had it to where there's like an automatic file added to it. So at least for those core JDK classes, like they should always be loading from this shared archive that's kind of pre-processed, which should improve startup. But the amount of improvement this offers is pretty small. Once you get to an application of anything beyond hello world, the difference you see in timing for startup from this is pretty small. In JDK 10, we added AppCDS, application class data sharing, that allows developers to actually create a pre-processed archive that also includes all the application files and, of course, obviously your dependencies as well. So that actually really extends that benefit to any size of application. And so it makes it much more consistent to where you actually see that improvement. And it's actually pretty significant. It will obviously come down to if you're making some sort of connection to like an external service, that's going to take up a lot of time. But and like a really simple, the Spring Boot Pet Clinic test app that the the Spring engineering team put together. I can't remember the times offhand, but I think it was about a 20% reduction in startup time when I'm using AppCDS. why I'm bringing this up, in JDK 13, we made it even easier to work with by having dynamic CDS archives. And so pretty much the way is, if you want to use app CDS in your applications or at your job, you could just do the Java command line, and then you do archive classes and exit, and then you would give the name for a shared archive, and then you just have your startup script the rest of the way you would have here, this jar application or whatever. And then to read from that shared archive, you would then do shared archive file and then the name of the shared archive. And so it will load from it. Like I say, it's a pre-parsed file, so it will load faster. And then this is also memory mapped. So if you had multiple applications running on the same host, then they can all reference the same memory location, and that would actually reduce the memory usage as well. But again, that is only the case if you're running multiple JVM processes and they're all using the same shared archive. Something I also kind of talk about in another presentation is, but the actual code that you write yourself is pretty small compared to all the dependencies you depend upon. And that would also be kind of the case with these shared archives, that when you're building up this archive, what it's really building up is primarily the underlying dependencies depend upon. So if you have like a shared tech stack at your organization, maybe you're doing everything with Spring or MicroProfile or Quarkus or whatever it might be, you can create a kind of a shared archive that's kind of following those underlying dependencies, and then share that between your different applications, instead of necessarily having to create a new shared archive for each new application. Just because most of the benefit comes from those underlying shared dependencies. But something definitely worth checking out, particularly I think for any application, but really could be important if startup time is really important for your application. ZDC, Z doesn't stand for anything. It's just, for some reason, they just wanted to name a garbage collector Z. It became a standard feature with JDK 15. It had several rounds of experimental before that. But it's a fundamental redesign of garbage collection on Java. And the goal of it is to have extremely low latency, and also being able to handle extremely large heaps, terabytes and beyond. Currently, ZDC is single generation, which only matters if you're really into garbage collectors. But the plan is at some point to make it multi-generational, like the G1 garbage collector or Parallel or the other garbage collectors. But if you want to use ZDC, the low latency will primarily benefit applications that are doing communication, where you want to have as fast a response as possible. There might be a bit of a trade-off depending upon usage for when it comes to overall throughput. But if you want to try it out, you can just use it with use ZDC, set your heap size, and then you probably want to turn on debugging logging for a garbage collector, so you can properly compare it to, if you're using G1 or Parallel or maybe Serial, you can compare the performance between them. This is another, I think, easy big win for developers. We've all ran into those annoying null pointer errors, and we've ran into it where it's on a line where it could be one of several different values, could be null. So now with helpful null pointer errors, you'll actually get a much better message saying like what exactly was null on that line, and not just saying a null happened, a null pointer exception happened on line 7 in main. It will say like, oh, okay, this local variable local 1 was null. So it makes it much easier to track down those annoying NPEs. ARM architecture 64 support. Starting with JDK 17, all the major operating systems now have support for it, and the support for it will continue on as new features and enhancements are added for it. But now, with JDK 16, Mac OS is also supported. Linux was the first all the way back in JDK 9, and Windows was in JDK 17. A cool little feature, the simple web server. This was added in JDK 18, and the JEP for it is JEP 408. And so this was kind of added as a way, particularly for the need for newer developers to Java, but it could be very useful for everyone, where you can have a built-in server to the JDK that can just handle some simple needs. So from the command line, if you run jweb server, from the directory you ran that in, it will start up a server at HTTP 127.0.0.1 port 8000, and it will serve the files that are in that directory. The MIME types are automatically configured. So if you had an HTML file, it will be rendered as text HTML. If you have a Java file, it will be rendered as text plain, though these MIME types are also customizable by editing this file. You can also customize it. So if you don't want it running in port 8000, then you can just do -p and then whatever valid port number you wanted. You wanted a different binding address besides the loopback. Again, just provide a valid binding address. You do need a different directory as well. That's possible. You do need the full path. It doesn't do relative paths. So, if there's a subdirectory from the directory you're currently in, you will have to provide the full path to it, and you can't just provide just the name of the directory. If you want to change the output level, you can as well. The default is info, but there's also verbose. And there's a -h command for the help. One other thing to keep in mind is that actually, as I kind of cover in today's Inside Java newscast, with every release of Java, like performance is always a goal on improving it. And of course, performance, it's a multi-factor thing. There's startup, there's throughput, there's pause times, there's of course memory footprints. And with every release of Java, we see noticeable improvements. And here's just some really simple examples, again, of using the Spring Boot pet cleaning test app running on my local machine, which is like a Mac 2018, an Intel Mac 2018. So, the specific results of this will vary depending on your machine, but it took about 5.3 seconds for the application to start up, and it was using 673 megs of memory. But with Java 17, the exact same binary, so it wasn't recompiled, but the exact same binary built in JDK 8, I ran it on JDK 17. It took a little under 5 seconds to start up, and it used substantially less memory. And in JDK 18, it started up a little bit faster. It was using a little bit more memory, so I actually need to test out why that's happening, because it actually should be using less based upon a change. But yeah, your specific results will vary, but like I said, the performance improvements are pretty significant, especially when you're talking about going from JDK 8 to JDK 17 or JDK 18. There are some deprecations and removals and other changes to know about. The security manager that was deprecated for removal with JDK 17. Fundamentally, the security manager, these things can be better handled at the operating system layer. Very few organizations or Java developers were using a security manager to kind of handle the needs of making sure you're not getting requests from inappropriate locations or doing something like that. Like I said, operating system level is just usually a better way of handling it. And there was a big cost to the engineering side of the OpenJDK in supporting security manager. If you're making a living being an applet developer, I have some bad news. Applet's API has been deprecated for removal. So back in JDK 9, the Applet API was just deprecated, but now it's actually deprecated for removal. So here in some point, the somewhat near future, the API is just going to be removed altogether from the JDK. Some things that have actually been removed between JDK 11 and now is the Nashorn JavaScript engine that was removed in JDK 15, and the CMS garbage collector, the ClearMark sweep garbage collector, was removed in JDK 14. This was removed because the G1 garbage collector, which became the default garbage collector with JDK 9, it's just a fundamental, it's a fundamental improvement and upgrade over the CMS garbage collector. So it's just there's no point in having both, and the G1 garbage collector was just better. So that's why CMS was removed. Nashorn, it was removed, but it's actually still on the OpenJDK GitHub. It's still being maintained to some extent. So if you still actually need it, it's still available. It's just no longer built into the to the JDK by default. There's some other changes to know about as well. With JDK 17, the JDK internals are strongly encapsulated by default. So back in JDK 9, the introduction to the Java module system was introduced, and it caused some issues. So initially, we had the default argument of equal access permits was a default argument to when you started the JVM, which allowed for reflection to any of the JDK internals. JDK 16 illegal access permits was removed as a default argument, but this would still work with JDK 16. With JDK 17, this no longer works. This is a no-op now. So you can't just go into all the internals just by default. That said, there are certain APIs that are still can be reflected. So it's because that's just the reality of like many libraries and applications still like need access to SunMISC unsafe. Eventually, illegal access will be removed. So if you try to put that into your startup script, you'll get an error. That said, if there is like some sort of JK internal API you do still need to get to, you can still do the add opens from the command line or add it to your jar manifest. So I covered like a lot of new features and new language features and new runtime features. But there's also a lot of new classes, methods, and fields and so on that are also being added. And if you go to the official JDK Java doc, I actually need to update this because it's no longer in early access. They have like this, starting with JDK 17, they show like the differences between what new features and new fields and command lines or new methods were added between releases. So you can definitely check that out. I know at least like one class that's used often, string, has actually had a whole lot of new methods that have been added between JDK 11 and now that make it a lot easier to work with, like removing starting empty space, moving trailing empty space. There's been a lot of stuff that's been kind of like added, particularly to string, but there's also been a bunch of other stuff. So definitely check that out, as I don't have the time to kind of go into all this during this presentation, because I guess you don't want to be here till midnight. All right, so let's actually get a bit into the future of what's going to be coming for Java in some of these upcoming releases. So I mentioned how pattern matching is going to become a pretty big topic for Java going into the future. And the second example of pattern matching that's going to be added to Java is pattern matching for switch. It's currently in preview 2, and the jump for it is 420, though there is actually going to be a third round of preview. And I haven't updated these upcoming slides, but I can explain the differences for it, what's going to be happening. So pattern matching for switch, again, as we talked about pattern matching, there's going to be a predicate, so a matching on a field on the case, and then a pattern variable to set it to. So in this case, imagine like O is just some indeterminate type. You can match it, be like, okay, if O is an instance of integer, okay, then it's going to set it to the pattern variable of I, and then to the right of the arrow, as we talked about with the updates to switch, then you can have access to this I variable to kind of do whatever you want with it. In this case, we're just, printing out a string. Sorry about that. Or if it matches on long for L, a song like that. So one thing also, as I mentioned as well with pattern matching, is this pattern variable is flow scoped, so it's only available wherever the compiler definitely knows it's in scope. So like here, I is only in scope for this case. And what can be really nice, and I don't have a good example for this, I actually, like I said, need to update it some, is like, or I guess it's going to jump to here, is like, what's going to be added, which is also what's called guard patterns. And so here it's like, okay, I have a case. It's like, okay, if it's of the type triangle, then I'll assign it to T, and then I can do a test on T to see like, okay, if this area is greater than 100, well, then that's a large triangle, and then only then execute this part of the case. For any other type of triangles, for any triangle that's below 100 in area, then that's a smaller triangle. So one of the major differences with the third round of preview for pattern matching for switch is instead the guard pattern would be initially denoted by a when clause. So you would do when and then anything here, and then here it's like, okay, if like the area of the triangle is over 100, and then maybe it's like a right angle, so like you have some tests to say like is at least one of the angles on it 90 degrees. You could also do like an and here as well. But we can also see, because of this pattern matching, like we don't have to come up with like different variable names for every case. We can reuse t in each subsequent case, because t here is only in scope for this case, and then this is like a completely new variable as far as the compiler is concerned. So that can be very helpful if like you have like, or like in this other example, I have like integer, and so like if it's integer more than 100, then something like this. If it's integer between 0 and 100, then I have something like this. I can continue to say like reuse I throughout this switch case, like the letter I for the variable. I don't have to come up with like a bunch of different names for it, which can be, again, a bit cleaner and easier to understand. Oh, nice. Yeah, so someone mentioned all the new features since JDK 8. So yeah, definitely check that out. That could be very helpful as well, to kind of give a full list of all the new language features that have been added. Also, with pattern matching for switch, we can also handle nullability in the default case or in the cases. So if you had a case null, you can now do that if that makes sense. Also, with pattern matching for switch, it will also be able to like read a sealed hierarchy. So I was just talking about earlier how oftentimes when you're writing a switch expression, you're going to need a default case in it. If you're referencing a sealed hierarchy and you covered all the different potential subclasses for that sealed hierarchy, then you don't need a default case. And this can be very nice as well if maybe that sealed hierarchy might be changing a little bit over time. If you were to say hypothetically add a new case to it, then that switch expression will get an exception because you don't have a default case, and it will say like, hey, it's not exhaustive anymore. So that can be very helpful. This is kind of gets back to a little bit of verbosity and stuff like that, and then being a little bit safer with some of these changes going forward. That, like, again, if you add a new type to a sealed hierarchy and you don't cover it in your switch expression, you'll get a compile error. Two other really big things is record patterns and array patterns. And actually, this has been split recently. So record patterns will be actually part of JUP 4 or 5. And I think it's going to be part of JDK 19. I don't know if it's official yet, but it's almost certain that it's going to be part of JDK 19. Array patterns will actually be separate and will be coming later. So it won't be part of JUP 4 or 5. So I actually need to update this slide. This is sometimes the problem when you talk about future projects, future items, is things can change a little bit. But with record patterns, instead of like here without record patterns, like if I wanted to get like a specific value outside of rectangle, like I want to get the upper left value of this colored rectangle, like I had to do like, okay, if rectangle is not null, check it. And if that, this colored point isn't null, then I'll get that something out of it. Again, very verbose and stuff like that. So instead, I'll just jump to the end of it. I can just directly reference, I'm like, okay, if rectangle is an instance of if rectangle is an instance of a rectangle, I can just directly reference the fields within that record and then reference that instead of having, I can even go further to where if it's an instance of record, I'll just reference directly the color for one of these points and reference them that way. So it just becomes much cleaner. Instead of having like that whole nesting down, I can just reference some fields directly from a record. And array patterns, again, that's going to be a separate JEP, but it will kind of work somewhat similarly. Like, let's say I want to reference a specific item from an array, instead of like having to go through like a loop on it, or having to do, some strings and then the square brackets and then the item I want to pull out, I can just directly reference like, okay, I want to get the first and second item from it, S1 and S2, and do whatever work instead of, again, the older way of referencing items. And this will also even work within like a multi-dimensional array as well. And you can even combine it with a var if you just kind of wanted to be a little bit, you don't have to necessarily type out the different types within that array. You can also get access to all the different early access builds. Well, of course, JDK 18 is no longer early access. Now it's JDK 19 is available for early access. Also, we have Loom, Panama, and Valhalla. So Loom is about adding virtual threads, which is really going to vastly help when it comes to parallel processing, parallelization within Java. And it's starting to get closer and closer. So definitely check that out here. Panama is about the foreign access APIs. So if that makes sense for your organization and you're relying on a lot of like native methods and stuff like that, definitely check out Panama. And then also there's Valhalla. There's also now the new Oracle. So one of my colleagues, Kristen Stein, we released a new Oracle GitHub action, which actually has much easier access to these. That's not it. It's somewhere here. I'll provide a link later. But the Oracle GitHub action, which can provide easier access to these, like the Loom, like your early access builds and Loom, Valhalla, and Panama. So that way you can actually incorporate that into your build process and see, like, if you are really looking forward to like virtual threads or to a lot of the big changes coming from Valhalla, you can actually start consuming those different builds into your build process to see, does it break anything or does it provide any improvements? And we would love for you to do that. And we would love to have any feedback on whatever your experience is. Breaks would be the feedback we want to most know about. If we break something, we obviously make sure we want to fix it, but also just any other experiences you have with it. So definitely, yeah, I'll go GitHub. There we go. There we go. So yeah, Oracle Accents, Setup Java. Like I said, this can give you much easier access to some of these other new early access builds. So with that said, that is actually the end of the presentation. As I said, you can go here to get access to the slide deck. Here are some of the slide notes I referenced. I actually need to update this to the Java 18 release notes. I also have a bunch of code examples at these locations. And also, I know things getting a little bit better, but I know many plate developers and organizations are still stuck on JDK 18. Maybe about a year ago, this developer called I'm not gonna butcher his last name, but he used to work at Netflix, and during his time at Netflix, like at least the team or organization he was with, like there was a difficulty when it came to the idea of upgrading beyond JDK 8. And so he writes about his experience with that in this blog article about the impossible going beyond. It's impossible to get to JDK 11. That was like colleagues were saying. And the big fundamental thing with that is, the big takeaway is it really just comes to upgrading dependencies. And then, sometimes when it's upgrading dependencies, you're going to run into some breaks, or maybe that dependency, there isn't a, post Java 8 example for it because maybe it's no longer being maintained. So he just kind of goes through his experience and that. But like I said, the big takeaway is like, you just want to keep your dependencies up to date, which is something you want to do anyways, outside the context of what JDK version you're on. You really want to be on the latest versions of dependencies for security, performance, and all of that. So with that said, if you have any questions, I guess feel free to unmute yourself and I'll be more than happy to answer them. Or if you just want to type them out as well, I'll do that. I guess while you're taking the opportunity to do that, I'll get back to the question that was asked earlier about any good frameworks for performing a series of validations in a business flow. So if you're doing like business validation, Cucumber could be a good example. So the Cucumber is an example of what's called doing business or behavior-driven development, BDD, where you do where the concept is like a given a state, like given this user is an admin and they have these privileges, when they try to do X, then the result of that should be this. And usually that BDD kind of handles things at a higher level of actually going through some sort of flow in your application state. So Cucumber would be a good example of that. Now, my experience with Cucumber has been kind of mixed. When I've done it, it's been at organizations that were very immature when it came to automated testing. So that part is part of why we didn't really had that much success with it. But that could be a good way. But that is its goal, is to kind of take business flow, business concepts, and then actually kind of write that into code that can actually be tested with. Hopefully there could be some good examples of people actually applying it. Unfortunately, like I said, just when I tried to do it, it was at organizations that were very immature when it came to automated testing. Any other questions? I'd be more than happy to answer them. Yeah, so are there any runtime benefits to using record, or is it purely syntactic? And yeah, they're really fundamentally just classes. There's not a whole lot of performance runtime. Now, there is one runtime benefit when it comes to serialization. So serialization is a very, it's a source of a lot of bugs within the JDK, as Brian and many other the senior Java people would like to tell you. And so how records actually benefit when it comes to serialization is what makes serialization such a big issue is it has like these magic methods that reconstruct the object. And when you're actually reconstructing a normal Java class with serialization, it's not actually calling the constructor for that class. It's like creating like an empty object, building up all the fields, and then creating it, which could cause issues with invariants. Like, let's say you, like going back to my person example from this record, let me just quickly jump back to that. So obviously I'm not doing any validation on any of these fields in this example, but let's say first name and last name, they can never be empty strings or something like that. Like they can't be null, they can't be empty strings or something like that. And within the constructor for it, I'm doing some sort of checking for that. With serialization, that constructor is never actually called. So you could be deconstructing an object that is not matching that requirement. And there's also a few other more significant security issues that could also happen as well. For records, when they're deserialized, the canonical constructor is actually called, so you can't actually run into those invariant issues. So that is really the primary way where records could be beneficial. There could be possibly some runtime advantages for some frameworks when using records, because they don't necessarily have to maybe do as much checking, because like only the fields declared within the record header can be there. You can't have any instance methods. But I think really primarily there's not much of a runtime benefit as far as performance is concerned. And yeah, so yeah, do records help with memory inefficiency and CPU at least as of right now, no. And maybe at some point in the future, but like I wouldn't really count on it. Like I said, it could be, I don't know, maybe Valhalla does something like that, but that's just pure speculation on my part. All right, any other questions? But yeah, like right now, like we see with deconstruction with records, that's gonna be like another benefit when, retrieving items out of a class or something is something that's pretty common, a pretty common need. Deconstructors or the record pattern matching is going to make it that much easier for records. And there's going to be even more things that are going to be built upon records in the future that's going to really also make them very nice to work with. All right. Great. Awesome. Yeah, thank you. Yeah, thanks for the compliment, William. I'm happy to help. Happy you enjoyed the presentation. And if you have any questions later on, feel free, again, to reach out to me at Billy Korando on Twitter or billy.korando@oracle.com. And also my DMs are open on Twitter, so you can reach me through DM as well if you have like a longer question, or you just don't want to, post it out there publicly, the question that you have.
Seems like I lost.
Yeah, thank you.
Okay. Well, thank you, Billy. That was really good. And thank you, everyone. Yeah, if there's no question. Just one small question I might have missed too when you talk about Project Loom. So which version of Java. Do you know that, or have they decided which version is going to be?
So I mean, it should hopefully, like, it's probably going to be at least in a few rounds of preview or incubation before. Maybe I think maybe fingers crossed, JDK 20 is where it could be the first one. But you know, when it comes to software development, things change, things get pushed back. So don't quote me, don't post it out there. Be like, hey, Billy Korando said JDK 20. It's not delivered and just send angry hate mail to me. So and as that, you know, it's probably going to be delivered at least in multiple parts, because that's actually the case with a lot of these features where it's actually delivered in multiple parts overall. But hopefully virtual threads, like I said, as a preview or incubation feature, then JDK 20, maybe, hopefully.
Okay, cool. Thank you, Billy.